Chemical bonding is one of the important concepts in the study of chemistry and is important in understanding material structures, properties, and their reactions. Chemical bonding means it is just attraction, force of attraction. Force of attraction between two atoms or two molecules or any two ions. When two atoms come closer at certain point, they are attracted towards each other and they are held together. They form compounds. That is bonding, right? Why and how do atoms combine and form molecules or compounds? In this lesson, we are going to discuss. We all know that we have more than 118 elements, right? From these 118 elements, millions and millions of compounds are formed through chemical bonding. Only 6 elements, namely helium, neon, argon, krypton, xenon, radon, they don't participate in any chemical reactions. That means they don't form compounds. Remaining elements, remaining elements, that means atoms of remaining elements, they participate in chemical bonds and they are producing compounds and molecules. Why do atoms combine? To answer this question, the answer is hidden in the electronic configuration of inert gases. If we observe the electronic configuration of inert gases, in their outermost orbit, neon, argon, krypton, xenon, radon, in their outermost orbits, all these elements have 8 electrons. We say valency electrons in their outermost orbit. Electrons which are present in their outermost orbit are called valency electrons. These elements are having 8 electrons in their outermost orbit, except helium. Helium has 2 electrons. That means in s orbital, 2 electrons are there. 2 electrons. That means it is fully filled. In s orbital, for only 2 electrons, accommodation is present. So 2 electrons are present in s orbital in hydrogen. So in helium, so helium is stable. Remaining elements want to get this kind of configuration. That means they want to get electronic configuration of inert gases, because inert gases are stable, they are not participating in any chemical reactions. That's why they are called noble gas, inert gases, zero group elements, or 18th group elements, or 8th A group elements. We have different names. So other atoms want to get stable configuration like inert gases. That's why they participate in chemical bonding. Attraction forces between two atoms or two molecules or ions is called chemical bonding. See, to understand chemical bonding concept, we have to observe the configuration of inert gases. We know helium, neon, argon, krypton, xenon, and radon. These are called inert gases. Inert gases are zero group elements or 18th group or 8th A group. Except helium, remaining elements don't participate in any chemical reactions. They don't participate in any chemical reaction. Means they don't produce any compound or molecule. That means they are stable. This can be concluded from observing the electronic configurations. Let us observe configuration of these elements, neon. Its atomic number is 10. It has configuration 1s2, 2s2, 2p6. See 1s, this is 1, 2, 2. This is second orbit. We can write 1, 2 plus 6, 8. This is the second orbit, so 2 plus 6, 8 elements. So in the outermost orbit, neon is having 8 electrons. Let us take another one, argon. We write 2, 8, 8. You can get it, you writing like this, 1s2, 2s2, 2p6, 3s2, 3p6, right? 1s first orbit, 2s and 2p, second orbit, 3s and 3p, third orbit. See, in first orbit, we have 2 electrons. So I am writing 2. In the second orbit, this is second orbit, 2 plus 6, 8 electrons. Again, 2 plus 6, 8. If you observe last, this is the third orbit, 3, 3, third orbit. So in the third orbit, last orbit, we have 8 electrons. In the earlier case, also 8 electrons. So, like this, krypton, xenon, and radon also, they are having 8 electrons in their outermost orbit. This is the speciality of inert gases. So they are not participating in any chemical reactions, and they are stable. They are non-reactive. They are not reactive. Okay. So other atoms want to be stable. For that, they try to get 8 electrons in their outermost orbit. Outermost orbit. That is called octet rule. They wanted to get octet configuration. Then by getting octet configuration, they will become stable. So for stability, atoms participate in chemical bonding. I hope you understood. Out of this neon, argon, krypton, xenon form compounds. Remember, this is exception. Xenon forms compounds. Next, helium. These elements are having 8 electrons in their outermost orbit. Helium, it has only 2 electrons, only one orbit. So that one orbit, we have s orbit. So s orbit, we only there is accommodation for only 2 electrons. So it is completely filled. So that's why this is, that also considered as inert gas. That valency is called, we call them duet. This is octet, this is duet. So if any atom contains 2 electrons or 8 electrons in their outermost, they are considered to be inert and they are stable. Let us discuss different types of chemical bonds. Mainly in this session, I am going to explain ionic bond. Before going to begin, I want to explain one more thing, that is, when two atoms, here two atoms, in the beginning, atoms possess more energy. Atom possess more energy. See, we know inside the atom we have nucleus. This is positive charge. Again, this is also an atom. The center has positive charge. Around these electrons are revolving. You know it. Between these two electrons, there will be repulsion because both are negative charges. Between like charges, we have repulsion. Between unlike charges, we have attraction. You know it. So here between centers, between nucleus, see between these nuclei, we have repulsion because both are positive. Between nuclei, we have repulsion. Between electrons, electron of this atom and electrons of this atom, repulsion is present. That means when two atoms come closer, they have repulsions, right? This repulsion after certain time, when they come close, here, they lose energy. They start lose energy. In the beginning, they have more energy. When they are going to close, when they are getting close to each other, they lose energy. That means at a certain time, this repulsion will be decreased. This repulsive forces will be decreased at certain length. That is called bond length. Suppose say these two atoms comes close like this. Then this length is called bond length. At a certain length, the repulsion forces are reduced. There will be attraction. That force of attraction is called chemical bond. I hope you understood. When these two atoms combine, molecule is formed. Molecule gets low energy. Atoms have more energy. Individual atoms have more energy. Molecule has low energy. So after formation of the bond, the system's energy will be reduced. In the beginning, atoms have more energy. Sharing, by gaining or sharing or losing electrons, atoms try to get 8 electrons in their outermost orbit to become stable. That is the reason they participate in chemical bonds. Let us discuss ionic bond. Bond means force here. Bond between ions is called ionic bond. Bond between ions is called ionic bond. Here ions must be dissimilar, not same ions. One must be cation and the other must be anion. That means between cation and anion, ionic bond is formed. I will make you clear by taking this example. Best example is sodium chlorate. This is a compound, everyone knows. This is called table salt. This ionic bond always present between a metal and non-metal. A metal and non-metal. Here sodium is metal. Sodium is metal and chlorine is non-metal. Chlorine is non-metal. Sodium belongs to 1A group. 1A group. Chlorine 7A group. So 1A group elements have the tendency to lose electrons. That means sodium loses electron. Sodium loses one electron and gets positive charge and it becomes cation. I am writing that equation. See here Na. Na has the tendency of losing electrons. So Na atomic number is 7. Its atomic number 7. It has configuration of 1s2, 2s2, 2p6 and 3s1. Okay, 1s2, 2s2p. This is second orbit. This is third orbit. We can write 2 electrons, 2 plus 6, 8 electrons. Then last we have 1 electron in third orbit. This is valency orbit. So we have 1 valency electron, 1 electron in the outermost orbit of sodium. Here, one extra electron is present in the outermost orbit of sodium. If it loses this electron, now it has left with 8 electrons in its outermost orbit. So that's why it loses this electron to become positive charge to get stability. So now I am writing that equation. Sodium, put one arrow mark here. Now sodium is becoming Na plus ion, sodium ion, positive charge, cation. It loses one electron. So that last electron is written as E minus electron. Okay, Na, configuration of sodium is 281. Configuration of Na plus 28. Don't write 1 here because sodium loses one electron. One electron is given to chlorine. So that's why we write only 2A. So this is electron 1. 2 plus 8, 10, 10 plus 1, 11. So here also 2 plus 8, 10, 10 plus 1, 11. In this way, you have to balance the equation. So Na gives rise to Na plus electron. Now, chlorine. Let us write chlorine. Chlorine is non-metal. Its atomic number 17. It has the configuration of 1s2, 2s2, 2p6, 3s2, 3p5. 1s2 first orbit, 2s2p second orbit, 3s3p third orbit. We can write 2, this 2. I am writing this 2. 2 plus 6, 8. Again 2 plus 5, 7. If you see, in the first orbit we have 2 electrons. In the second orbit we have 8 electrons. In the third, that means outermost orbit, chlorine is having 7 electrons. It needed 1 electron. It needs 1 electron to get 8 electrons or octet form. So this chlorine needs 1 more electron. This chlorine gets this 1 electron from sodium. Sodium already loses 1 electron. That last electron is taken by chlorine. Now chlorine becomes chloride ion. I am writing that equation here. Chlorine, right? Put arrow mark. Now chlorine is receiving electron from sodium. So whenever one atom receives, you must write left side of the arrow mark that particular electron. Here write chloride. Observe the difference. See here, in Na plus electron, sodium loses electron. Okay, that's why I wrote right side of the arrow mark this electron. In this case, chlorine is receiving, taking 1 electron. So that's why left side of the arrow mark I write here electron. That is the difference. So sodium, by losing 1 electron, it becomes Na plus sodium ion. Chlorine, by gaining 1 electron, it becomes negatively charged particle. It got negative charge. Between these two charges, means this is cation and this is anion. Between these two different charges, we have forces. These forces are called ionic bond. Ionic bond. One more thing you have to observe, that is sodium 7. Its atomic number is 7. See, configuration is 281. By losing this electron, sodium ion getting 2, 8 configuration. 2, 8 means this is 2 plus 8, 10. 10 is neon. See, so sodium, by losing 1 electron, it is getting inert gas configuration of neon. Neon is stable, so sodium ion got the electron configuration of neon. In this way, it is becoming stable. Again, here chlorine. Chlorine in the outermost orbit, it has 7 electrons. By taking 1 electron from sodium, now it has 8 electrons. Now I am writing here chlorine. Here I am writing 2, 8, 8. In chlorine, we have 2, 8, 7. This is the configuration. When it receives 1 electron, now it has 8 electrons in their outermost orbit. So this is equal to argon. 2 plus 8, 10, 10 plus 8, 18. 18 is the configuration of argon. That means chlorine atom, by getting 1 electron from sodium, it is getting configuration of argon. That means this also becoming stable. This chlorine got configuration of inert gas. So in this way, both sodium and chlorine are become stable, right? So in this way, ionic bond is formed. Let us take another example, magnesium chlorate. You know magnesium? Magnesium is a metal. It is in 2A group, right? Magnesium atomic number is 12. Its configuration, we write 2, 8, 2 plus 8, 10, 2. 2, 8, 2. If you don't know how to write this, 1s2, 2s2, 2p6, 3s2. First write this. 2, 2s, 2p. This is second orbit. 3, third orbit. So 2, 2 plus 6, 8, then 2. So magnesium if we observe in its outermost orbit, it has two valency electrons. If it loses these two electrons, in the next orbit we have 8 electrons in their outermost orbit. So for that, this magnesium loses 2 electrons to get octet rule, octet configuration. So I am writing this equation. Mg, put arrow mark. Mg becomes Mg2 plus. This is ion Mg2 plus. By losing 2 electrons, so that last electrons should be written right like this, 2 electrons. So now magnesium becomes Mg2 plus ion. It got positive charge, two positive charge on this. Now chlorine. See this chlorine, we have to write two chlorine atoms. Cl2 means two chlorine atoms. While writing these expressions, don't write Cl2. Okay, write 2Cl only. Now these two chlorine atoms, right? Two chlorine atoms. Each chlorine atom receives one chlorine atom only, right? So this magnesium loses 2 electrons. These last electrons are taken by chlorine. One chlorine takes 1 electron, another chlorine takes another electron. So two chlorines are receiving 2 electrons. So here I am writing 2 electrons. If an atom receives electrons, you must write them left side of the arrow mark. Here this is left side, arrow mark. On this side I wrote 2 electrons. Now you have to write two chloride ions. Now this can be written as Mg2 plus. This is cation. Now 2Cl minus. These are anions. Between these magnesium ion, cation and two chlorine atoms. Two chlorine ions. They come close and they become MgCl2. See here, magnesium configuration is 282. By losing these 2 electrons, it is getting 2,8 configuration. See, outermost orbit we have now 8 electrons. This is configuration of neon. That means magnesium, by losing 2 electrons, it is getting electronic configuration of neon. Here chlorine also, by taking 1 electron each, one chlorine. In chlorine we have 287. This is 7 electrons it is having in their outermost orbit. So 7. Now it takes one more electron and becomes 288. In its outermost orbit, it is having 8 electrons. So in this way, magnesium and chlorine gets the configuration of inert gases, neon and argon respectively, and they become cations and anions. Between them, force of attractions are present. These force of attractions is together called ionic bond. Another example, disodium monoxide. Disodium monoxide. N2O. How ionic bond is formed in this disodium monoxide? Let us discuss. I am writing here N2. You must write, don't write N2 here. Night sodium this is. Okay. Na2, sorry. Na2O. Na2O. Sodium disodium monoxide. Now I am writing two sodium atoms we have. That two sodium atoms we have to write 2Na. Don't write Na2. Okay. 2Na you must write. Now sodium atom has the tendency to lose electrons because the sodium belongs to group 1A group. So Na becomes Na plus. Here two Nas, two sodium atoms. So we get 2Na plus. That means two sodium positive ions, two sodium cations we got. So this sodium is losing 2 electrons. One sodium loses 1 electron. So two sodium lose 2 electrons. That's why I'm writing 2 electrons here. Now oxygen. Oxygen, oxygen always has the tendency of taking electrons, gaining electrons. Its configuration is 2, 8, No, no, no. 2, 4. 2, 1s2, 2s2, 2p, 4. Okay, oxygen atomic number is 8. So we must write 2 comma 6. 2 comma 6. See in the, see, 2, 2 plus 4, 6. 2 comma 6 we have to write. Now, in the outermost orbit, this is outermost orbit, we have 6 electrons. That means 2 more electrons are required to complete that octet. So this oxygen receives 2 electrons. Oxygen 2 receives. These 2 electrons are loosened by lost by sodium atoms. So now I am adding these 2 electrons. These 2 electrons. So this oxygen receives 2 electrons from 2 sodium atoms, and this becomes O2 minus oxides. 2 oxides are formed. Now between these 2 sodium cations and 2 oxides, oxygen anions, between them they come close, there will be attraction forces, that is written as Na2O. Disodium monoxide is formed. One more thing you have to observe, that is, see a sodium configuration, 2, 8, 1, right? 11. 2 plus 8, 10, 11. In its outermost orbit, it has one valency electron. This is lost by this sodium, and when it becomes cation, it has only 2 comma 8 configuration. This is loose. Sodium loses this electron. Now it left, that sodium atom left with 2 comma 8 configuration. 2 plus 8, 10, that is neon configuration. So sodium atoms, by losing one electron, they are getting configuration of neon. In this way, they are becoming stable by becoming inert gas configuration. Here also see, oxygen, in its outermost orbit, it has 6 valence electrons. After taking 2 more electrons from sodium atoms, now it has, here we write 2 comma 8 we write. 6 plus 2, 2 electrons are added. So 2, 8. In its outermost orbit, now it is having 8 electrons. That means this is the configuration of neon. So oxygen is also getting configuration of neon, and sodium also getting configuration of neon. In this way, both atoms become stable. So this is all about ionic bond. Oxygen belongs to 6th A group, or you can say 16th group. Okay, now let us discuss formation of aluminum trichloride, AlCl3. This is also example for ionic bond. See, how can you identify whether the given molecule has ionic bonds inside them? This is very simple. See here, aluminum is, it is metal, whereas chlorine is non-metal. Ionic bond always present between a metal and non-metal. Okay. Aluminum belongs to 3A group, or we say 13th group. In Roman number, you have to say this group, and if our numbers 1, 2, 3, so we have to say 13th group. So you must know in which group the elements are present. That is very, very important. Now chlorine, this is 7th A group. 7th A group chlorine, its valency is 1. Valency is 1. Aluminum valency is 3. Aluminum valency is 3. Aluminum, since it is aluminum is metal, it has the tendency to lose electrons. So aluminum loses 3 electrons. Its valency is 3. Its valency is 3. That means it can lose 3 electrons. Now I am writing aluminum, put arrow mark. This aluminum, by losing 3 electrons, it is becoming Al3 plus. Al3 plus. Now that 3 electrons we have to mention here. 3 electrons. Next, chlorine. 3 chlorine atoms. You must write 3 Cl. Right? Don't write Cl3. Don't put this 3 below this Cl. Now put arrow mark. These chlorine atoms are receiving electrons. So if they receive electrons, you must write left side of this arrow mark. Here only we have to write 3 electrons. So this chlorine becomes chlorides by putting minus symbol. 3 chlorine atoms are there. So we are writing 3 chloride atoms, 3 chloride ions. So in this way, we got Al3 plus and 3 chloride minus, right? They come close and they become AlCl3. This is formation of aluminum trichloride. See aluminum configuration I am writing. Aluminum atomic number is 13, 1s2, 2s2, 2p6 and 3s2, 3p1. 1s that is first orbit, 2s2p second orbit, 3 that is third orbit. 2, 2, 6, 8 electrons, 2 plus 1, 3. In its outermost orbit, aluminum has 3 electrons. 3 electrons. If it loses 3 electrons, now this becomes outermost orbit, second orbit. In this, it has 8 electrons. So that's why aluminum loses 3 electrons. By losing 3 electrons, now it gets the configuration of 2,8, that means neon. In this way, it is getting stability. What about chlorine? Already we discussed. Chlorine, atomic number 17. So we write 287. In its outermost orbit, we have 7 electrons. It requires one more electron to complete octet. So it must have 8 electrons. So 1 is needed. It takes from this aluminum, 3 chlorine atoms each, they take 1 electron from aluminum. Okay. Now it got 288. This 7 becomes 8 by taking 1 electron. 2 plus 8, 10, 10 plus 8, 18. This is the configuration of argon. So aluminum is getting aluminum by losing 3 electrons. Aluminum by losing electrons, it is becoming cation. Aluminum loses 3 electrons. Okay. 3 chlorine atoms, they take these 3 electrons, 3 chlorine. 1 chlorine takes 1 electron. Second electron from aluminum, chlorine receives. Third electron of third element is received by chlorine. 3 chlorine atoms, they get these 3 electrons from aluminum. In this way, they get stability.